All right, so we'll go ahead and get started. Unfortunately, my Apple Pencil is still not working, which that seems to be a problem. So, I'm gonna do the best I can with my mouse pad here and like typing. So, all right, so final review here. So the first question here is what is the IUPAC, which is our orgochemistry term for, that special naming system for the following compound. So we have a ring here. We have a one, two, three, four, five, six-membered ring. So it's all single bonds. So we know we're dealing with cyclo because it's a ring. And then we know it's going to end in ane because it's all single bonds. So now it's a matter of, oh, sorry, one second. I opened up the chat. Okay. So now it's a matter of that parent chain naming, um, so we know cyclo because it's a ring, then hex because it's a six members, and ane because it's all single bonds. Okay. And then our next step is to take care of the branches. So we know that, okay, so your guys' chats, we can go over the study guide after this. Is it the study guide that I posted in the announcements or the study guide from Canvas? Because I'm not gonna lie, I have not looked over the study guide from Canvas.
This is a stress.
The announcement. Okay, yeah, we can do that. Ah, bring this back up. Okay, so we know that it's cyclohexane. Now we just need to take care of um the branches, and so that would require us to number it. So it doesn't matter if we start at this branch or this branch as number one because they're both equivalent. I just need to make sure if I make one number one, I should go to the next one, next. So I could call this two rather than going all the way around this way. We're not going to do that. So we're going to go one, two. I can keep numbering it. Three, four, five, six. All right, but we already determined it's a six-member ring. So now I know that I have a branch coming off of carbon one and carbon two. They are two carbon branches. So we have a carbon here, a carbon here. They both happen to be the same. So I'm going to say one comma two diethyl, because they're ethyl branches and there's two of them, cyclohexane. So there shouldn't be a space, but I don't know how to make my typing go back and correct that. All right, any questions?
So, Professor, when you're doing a cyclo, the cyclo just goes before the number of carbon, right?
Yep, and cyclo just designates that it's in ring form.
And that's for five or six.
Yeah, any number of, and it could be a triangle, it could be yeah.
Okay, any just
Sure.
any complete.
Yeah.
Okay, okay.
So one of you guys messaged me saying to try to disconnect and reconnect the Apple Pencil. So I'm trying to do that on the side here. All right, I'm gonna erase this and we'll move down. All right, so the second one, we still have an alkane here. So it's still all single bonds, alkane. So we know that we're dealing with the ending ane. All right. And then we want to figure out the number of carbons in the main chain. So we want to do the longest possible chain. So if I start counting here, oh, connecting and reconnecting didn't work. Maybe something's like wrong with it. But all right, let's go back to using the keypad. Okay. All right, so we want to do the longest possible chain. So I'm just going to start here on the left side, um, just to figure out even what is the longest chain. So 3, 4, 5, 6, 7. Let's see if this would be, if I went this direction, it'd be 5, 6. So it looks like the longest chain is 7. Let's see, is there like a highlighter tool? No. All right, so looks like the longest chain here is 7, and then we have a bunch of branches. So we have a branch here, one carbon branch. So this is going to be a methyl branch. We have also a methyl branch here and here. So we're going to have a trimethyl, which we didn't get to see a lot of examples of. Alan might have threw you an example here or there, but all right. And then we have a 2 carbon branch. So this is going to be an ethyl. So next, we want to make sure we're putting our branches in the lowest order. So I was just numbering left to right at first to figure out even what was the longest chain and where the branches were, just to kind of get myself acquainted with this molecule. But I really truly need to make sure all those branches are in their lowest position, which if I do number left to right here, we have our first branch coming off of carbon 2. Whereas if I went right to left, it looks like, here, I'll draw 1, 2, 3. It looks like our first branch would come off of carbon 3. So it looks like I chose correctly the first time around, which is great. All right, so we have, and it's going to end in ane because it's all single bonds. It's going to be hept because it has 7 carbons in the main chain. So heptane. And then we have to take care of the branches. So we have 2 different kind of branches. And when we do that, we list them in alphabetical order. So E for ethyl is going to come before the M in methyl. So we're going to start off with 4 hyphen ethyl hyphen, and then here we get to do our trimethyl. So it's going to be 2 comma 3 comma 5, and I know you can't see what I'm typing until I hit submit, so I'm sorry, but 2 3 comma 5 trimethyl hept, because there's 7 in the main chain, ane because they're all single bonds. All right, so 4 ethyl 2 3 5 trimethyl heptane. Any questions about this one?
I have a question. How do we know it's a methyl and ethyl again?
Yeah, so let's put a different color here. All right, so here we only have 1 carbon branch. So there's only 1 carbon. So that's methyl. 2 carbons is ethyl. And so you see this one that I'm highlighting over right now, it continues where there's 2 carbons. And remember, carbons is where there's a point or at the end of a line. So what I've put red dots over, those are the carbons there.
Okay.
All right, anything else? All right. We'll move down here. Oh, why isn't it scrolling? All right. So which molecule has the highest boiling point? All right, so here we talked about boiling points and we made a graph, and that graph is on your reference sheet. So I finally compiled a reference sheet. I posted that this in my announcement earlier this afternoon. So you have that where you're comparing functional groups. But when you're comparing all of them of the same functional group, so these are all the same functional group because they end in an, or I'm sorry, ane, so they're all alkanes. When you have them all of the same functional group, you want to go with the one that has the most carbons in it. So a methane, that's going to be a one carbon molecule. Propane is meth, eth, prop, 3 carbons. Hex is 6. And octane is 8 carbons. And so the molecule with the highest boiling point is going to be octane because it has the most carbons. So we only default to that rule when they're all the same functional group. All right. There'll be a question like this where you're comparing all the same functional group, but there'll be other questions where you're comparing different functional groups. And in that case, it depends on where that functional group is on that chart that again is on your reference sheet. It's only when you're comparing the same functional group that the number of carbon comes into play. Any questions? All right, clear all my drawings. Go down. All right, so you have a couple questions where you just have to identify a functional group. So here we have a carbon double bonded to an oxygen. That same carbon is bonded to a hydrogen, meaning that this is a terminal carbon, right? It's not continuous with another carbon. So a C double bonded to an O on a terminal carbon is an aldehyde. If we had that same characteristic, a C double bonded to an O, but in the middle of a chain, that's a ketone. All right. So make sure we know our functional groups. That's something that is going to carry you throughout this test. Any questions here? All right.
I'm sorry, can you explain that again?
So we have a carbon. So here, this line that's continuous, this just means it's connected to another carbon, and that carbon can be X amount of carbons long. But the functional group itself is here, where we have a C double bonded to an O. So that brings us down to a couple options. It could be a ketone, aldehyde, or carboxylic acid. So we have to figure out what's also connected to it. And so because a hydrogen is also connected to it, meaning it's at the end of a chain, the carbon chain does not continue, it's an aldehyde. All right, that's an aldehyde. If the carbon chain continued, that'd be a ketone. So if we had this same molecule in the middle, where there was carbons on each side, that'd be ketone. It would be a carboxylic acid if instead of an H or another carbon, it was an OH. All right. Okay. So number 5, name the following organic compound. So first step in naming organic compounds, we want to identify the functional group. So here I see a double bond, so it's an alkene. And I know that alkenes have the ending -ene. All right, so I'm just gonna have that in the back of my mind or jot it down on my paper if I need to. The next step is to count the number of carbons in the main chain. So 1, 2, 3, 4, 5. But remembering I could count left to right or right to left. And I want to make the functional group the star of the show. So the functional group is this double bond. So when I number left to right, the functional group is between carbons 3 and 4. But when I number right to left, it's between carbons 2 and 3. So I actually want to number right to left in this case. Still has 5 carbons in the main chain though. All right. So because it has 5 carbons in the main chain, it is pent. I'll write this prettier at the end, but I'm working backwards here. So it's pent because there's 5 carbons in the main chain. Ene because it has an alkene bond. So my next step is to tell the audience where. So it's between 2 and 3, but I only need to tell them the lowest number. So I would say 2. And so if I stopped here, I'd be naming just the main chain. I'd have everything taken care of in the main chain. But off of this third carbon here, we have a branch, and we have just one carbon in that branch, making it a methyl branch. And so my job is to tell the audience, hey, we have a methyl branch coming off of carbon 3. So I would say 3 slash methyl. I don't know why I'm still writing because it's time for me to make this prettier. All right, so I'm going to type this to make it prettier. So it'd be 3 hyphen methyl hyphen 2 hyphen pentene. Any questions here?
Yes. So when you get so you got the 3 from the circle, the branch there.
Yep, because that's
So you
Mhm.
add that to the front. So why did you? I heard you, but I missed you. Why
Mhm.
did you go? Why did you choose? What made you choose left? I mean, right to left.
Yeah, so I want to put this, which is the functional group, at the lowest possible carbons. So I had this originally written out, right? 3,
Mm-hmm.
4, 5. But when I do that, this this alkene bond sits between carbons 3 and 4, versus when I number the opposite way, it's between carbons 2 and 3, and that's lower. So I want to choose that. I want to make it the lowest possible.
Okay, thank you.
Mhm. All right. So continuing naming. So our first step is to identify the functional group. So here I see this guy here. This is an amine. Anytime there's a nitrogen present, that's an amine. If that nitrogen is also connected to a carbon that is double bonded to an oxygen, that would be an amide with a D, but here it's just an amine. So my first step is to identify the functional group. The ending for that functional group is an amine. That's not very pretty, but I'll make it pretty later. All right, so then my next step is to figure out how many carbons there are in the main chain. So 1, 2, 3, 4, 5. And again, we can number left to right like I just did, or right to left. We want to make that functional group, which is what I have circled, the star of the show. So in this case, it left to right makes more sense because it puts it at carbon 2 versus carbon 4. So we're going to number like we read, just normally on this one. All right. So I have in the main chain, we have 5 carbons, so that's pent. And then we have anamine. All right. There's no branches or anything here. So I don't need to worry about that. But I do need to remember to tell my audience what carbon that amine group is coming off of. So it's coming off of carbon 2. So I would say 2 hyphen pent and amine. If there was any branches, I would put that information before the 2. All right, any questions? All right. Oops. Okay. Still naming structures here. So again, always the first step, identify our functional group. So here I see this guy, which is a functional group that I recognize. Really this O and H should be in opposite order if I wanted to be technical, but I made a mistake. But it's still the functional group of a carboxylic acid. All right. So carboxylic acids are a carbon bonded to an OH group, that same carbon doubly bonded to an oxygen. And they take on the ending enoic acid. All right. So what I've identified my functional group and what its suffix is going to be. My next step is to count the number of carbons in the main chain. Oops, I did not need to do that. Do. Okay. So this is my first carbon, right? Because that's an oxygen and a hydrogen there. So this is my first carbon. And then we would go 2, 3, 4. And then I would consider this here a branch. It's a 1 carbon branch, so it's a methyl branch. So carboxylic acids always start at carbon 1. So I made sure I numbered left to right to make sure that that's at carbon 1. So it's 4 carbons in the main chain, so it's going to be bute, enoic acid. All right, I'm working backwards. And usually the next step is to tell the audience where that functional group is coming off of, but we have 3 functional groups that always start at carbon 1 no matter what, and carboxylic acid is one of them. So I don't need to tell the audience 1. So then my last step is to take care of the branches. So like we see here, we have a methyl branch coming off of carbon 2. So I say 2-methyl butanoic acid. Any questions? All right, we'll keep chugging along. Right, we got another naming, and then I think we start to get, no, we're still keep naming. All right. So here we go, name the following structure. So we need to identify the functional group first. So here I see that an aldehyde, which that was one of our questions earlier where we identified it. This is an aldehyde, ugly writing, but we'll clean it up later. Aldehydes end in ANAL. That's their appropriate suffix. So the next step is to figure out how many carbons are in the main chain. So here's an example where it's not in the stick format, right? All the carbons and the hydrogens are explicitly written out. But I shouldn't let that stress me out because all I need to do is count carbons. All right, so I can count like I read left to right. 1, 2, 3, 4, 5, 6. Or I can count the opposite way. Right? So this is another one where our function, this is another one where the functional group always starts at carbon 1, no matter what. All right, so aldehydes always start at carbon 1, so I shouldn't even consider that second one. Or I'm sorry, the left to right, because we always want it to be at carbon 1. Okay, so that would be my proper numbering. All right, so these hydrogens, they look like there might be branches, but remember, branches have to have a carbon on them. So these are just hydrogens explicitly written out. So this molecule has no branches. All right. So 6 is hex, and then we're ending with that functional group suffix, which is ANAL, and there's no branches. So the full name for this molecule is hexanal, NL, however we say it. Right?
Okay. Question.
Yeah.
So, okay, the first time when we was counting,
Mm-hmm.
we started from the left side,
Mm-hmm.
and then you switched it. Like, how did we know to count it on the right side?
Yep. So this right here, what I just circled, that's our functional group. And we always want to make the functional group the star of the show. So we want to put him at the lowest possible carbon.
Okay. Thank you.
Yep. All right, so I'm just gonna leave this one on here. For this one, I don't have to scroll. So number 9, that is one of them where now we're comparing functional groups, which goes back to that chart, like I said, that's on your reference sheet. So we have an alcohol. Oh, I'm gonna type this. Undo, type. So you know what? I should start this thought process over. Okay, so to figure out which one is more soluble, we want to compare functional groups. And they all have different endings here, so they're all different functional groups. So my next step would be to figure out what each functional group is. So A ends in ANOL, which I know is an alcohol. Ethers, we didn't name them, but we talked about them in terms of comparing boiling point and melting point. So I see that this ends in the word either, and so I can make a safe assumption that its functional group is an ether. And then we have ane, which is an alkane. And then methene, which is an alkene. All right. So A is an alcohol, B is an ether, C is an alkane, and D is an alkene. All right. So once you've identified that, what you would do on the test is come to your reference sheet, which like I said, I posted this earlier, but for this question, I think it might be helpful if we pull it up. So all right. So this chart here, let's see if I can clean up some of this here. So this chart here that we're looking at the top, this is the chart that I'm referring to where you can compare them. So I see that alkenes and alkanes are down here. So alkene is the lowest, and it was asking me which is the most soluble. Then we have alkanes. All right, so it can't be that one because we're still pretty low on the spectrum. Then we have ethers, all right, which leaves us with alcohols over here. So alcohol is the highest here of all of them that we're comparing. So it has the highest solubility. So I'd come back over here. And so the most soluble is methanol, the
I
alcohol.
have a question.
Yeah,
So the higher the temperature per se, the more soluble it will be.
correct.
Okay.
Yep. So if this were worded like as least, the least was the methane, right? Because alkenes and alkanes are the lowest. All right. But it was worded as the most. So the correct answer is A. I was just running through a couple different scenarios for us on that one.
Well, if it was to say that like Ain and Ene share share a point,
Hmm.
um, which one will we pick? Like you get like if one was to share one and both was the answer, which one would we pick?
Yeah,
Or
so I wrote it that way because they don't have any questions where you have to compare those two.
okay, okay.
Yeah. All right. Anything else? Okay. And we'll keep going. Number 10. Oh, here's an example of the lowest. So this time it gave us all of the functional groups just written out. It didn't even ask us to like pick out those endings and identify them. So that's nice. We can just go back over to our chart here. So we're looking at the lowest. So we have a carboxylic acid, an aldehyde, an alcohol, and an alkane. So if I pull this back up, alkanes are down here. What am I doing here? Okay, so alkanes are down here, and everything else was above it. We wouldn't have alkenes or alkynes listed, so alkane is my lowest in this case. All right. So next, we come back to a couple naming questions. Well, I guess, sorry, any questions about number 10? All right. So next we come back to a couple naming questions. This one, number 11, I think we already did this. Well, we'll do it again. All right. So first step is to identify the functional group. So here's the functional group. I have an amine. This is an amine. And so it has the ending an amine. All right. So I know what my suffix is. I know where my functional group is. My next step is to count carbons in the main chain. So I see 1, 2, 3, 4, 5. And next I would consider if I want to go left to right or right to left, but this is going to be symmetrical just because they're both going to end up at 3. I can already kind of see that in my head here. So it's not going to matter which way I number. All right. So it looks like I want my carbon 3, sorry. Carbon 3 has my functional group. So we have 5 carbons in the main chain, pent, and then anamine, because that's my functional group. Working backwards, so in front of the pentanamine, I want to tell my audience where that functional group is. It's on carbon 3. All right. So 3 pentanamine. My next step would be to tell the audience about the branches, but there happens to be no branches in this case. That branch that I circled is a part of our functional group. So we've already taken care of that with the suffix. All right. Any questions on number 11? All right, so we'll clear this, move to number 12. We got another naming. All right, so this is a unique example that we haven't, well, did we see it? This might not be one we've seen before. All right. So I have 2 functional groups here. We have an amine functional group, right? We just were working with amines over there. And then I have a carboxylic acid. All right, I have that C double bonded to an O bonded to an OH. All right. So when you have 2 functional groups, you have to choose one. There's always one that's going to take precedent. In this case, carboxylic acid is going to take precedent. And you can even think of it as going back to that chart here, right? If we have competing functional groups in our molecule, right? We have a carboxylic acid and an amine, this group, right? Carboxylic acid is higher, it's going to take precedent, all right? So carboxylic acid is going to be our main functional group. We're going to treat the other functional group as a branch, Okay. So this is going to be our carbon 1. He's our main guy. And we're going to treat this amine group as a branch. So I'm going to number right to left because I want my carboxylic acid to be the star of the show. So I'm going to go 1, 2, 3, 4. All right. So with the carboxylic acid, the ending is anoic acid. So I have 4 carbons in the main chain. So bute. And then we're making the carboxylic acid the star of the show. So butanoic acid, right? So that tells us that we have 4 carbons and that there's a carboxylic acid. All right. And carboxylic acid is one of them where it's it's the always going to be on carbon 1, so we don't need to tell our audience which what carbon it's coming off of because it always has to be carbon 1. All right. But we're treating this other amine group as a branch. And so in that case, I need to tell the audience what carbon it comes off of. And it comes off of carbon 3. So I would say 3 hyphen. When we treat amine groups as branches, we call them amino. So the full name for this one would be 3-amino butanoic acid. Questions? And if you're a little freaked out by this, fair. Just remember your test is multiple choice. So hopefully you're a little bit familiar with this conversation that we had and you can kind of pick that out of 4 answers.
Can you say that one more time? When
Yeah.
we, you said when we turn that functional group into a branch is what?
It has instead of being called an amine, it then has the name amino. So that's why we said 3-amino. So this amine group is coming off of carbon 3.
Okay.
I have a question.
Mhm.
So we determine what is it called? The functional group by where the double bond is?
No, so there's actually 2 functional groups here. We want one is going to be like take precedent. One is going to be more stronger than the other, and that's going to be how we name it. And so in that case, it's the carboxylic acid. And that's why we turn the other amine functional group into a branch. And so I knew to make the carboxylic acid the more to take precedent. I keep forgetting to turn on the mouse. Based off of this chart, amine, we can use this same chart, so the increasing solubility, melting point, boiling point, to determine which functional group is stronger. So the carboxylic acid is stronger, so he's going to be the star of the show
Okay.
when there's
Okay.
competing ones. Yeah.
Okay, got you.
All right. Anything else? All right. More naming. I'm just kind of going down here. How many more do we have? Okay. So where the heck did we just leave off? Right there. Okay, number 13. So naming, bunch of naming. So first step, identify our functional group. So here I see a carbon double bonded to an oxygen, same carbon bonded to an amine group. And so that makes it an amide with a D. And amides have the ending an amide. All right. So amides are also one of them that always start at carbon 1. And you don't need to tell the audience that because it's always assumed. So I'm going to start my 1 here at the carbon, the amide carbon. All right. So then my next step is to continue numbering the longest chain. So I'm going to go 2, 3, 4. So I know it has the suffix an amide because there's an amide functional group. I know it's going to be bute because it has 4 carbons in the main chain. And then my next step would be to say if they're the branches and how to identify them, but there's no branches in this case, so this just makes it bute and all right. All right, so questions? Number 14. Number 14 is also a messy guy. We looked at it in the lab, which the lab was a long time ago though. So we'll look at it again. So there's special instances when we have a ring, a 6-membered ring that is double bonded every other carbon. When that is connected to the functional group of a carboxylic acid, which is a C double bonded to an O bonded to an OH, that ring and the carboxylic acid all together become benzoic acid, right? So everything typed out there covers what is circled in red. That benzoic acid, I think there's supposed to be another Z in there, or I'm sorry, E. So I think I mistyped that. But benzoic acid covers everything, which is nice. Then, so saying benzoic acid covers everything that's circled, which leaves me then just with these other branches here and here. So I would name this by saying benzoic acid, and then I just need to take care of the branches. So I take care of that by saying which carbon it's coming off of and putting it out front of benzoic acid. All right, so before I do that though, I need to figure out what carbon they are coming off of. All right, so I have to number my ring. Carbon 1 is always going to be the carbon that the carboxylic acid group is coming off of. Then with rings, once we've determined what carbon 1 is, we have to determine if we're going to go clockwise or counterclockwise. And so that all depends where your branches are. So you want to put your branches at the lowest positions after you've determined carbon 1. So in this case, I'm going to go clockwise, and I'm going to call this one carbon 2 and carbon 3. I could continue going, but it's not really necessary. So our branches here. So we're used to this bottom branch here, this 1-carbon branch. We know this as a methyl, all right? We've briefly talked about when we have elements, all right? So there's 3 different elements that sometimes can be branches: fluorine, iodide, and bromine. And when you have those, you just take the first part of the name and add an O. So for bromine, this branch is called bromo. All right. And I'm going to write this over here on the side. So for bromine, the branch is called bromo. For fluorine, the branch is called fluoro. For iodide, I think I don't know how to say it. Ido. But that's how you name single elements. And usually you really only see, oh, another one, sorry, I lied. You only see these ones. Chlorine as well, fluoro. All right. Pretty sure on your test is bromo and fluorine. I think that's all you have to worry about. All right, so benzoic acid, going back, covers everything that's circled. So now we just need to list our branches. We have 2 different branches, so I have to figure out which one to list first. So this takes us back similar to the first or second question we did when we have 2 different branches. We list them in alphabetical order. So B comes before M. So first in the name, I'm going to say 2-bromo. And then I'm going to say -2, 3-methyl. benzoic acid. All right. So the full name for this is 2-bromo 3-methyl benzoic acid. Questions? All right.
Yes, I have a question. I'm sorry. Is
Fine.
that the only one where it's going to be a benzoic acid? Like
Yeah.
the whole name is going to change?
Yeah, I believe this is the only example you see. In your owls, though, I think it's the last question on module 7, you might see benzanamine, which is when
Hmm.
this, can you see my mouse when I use my mouse?
Yes.
Okay, so that's when you still have this ring here, but instead of this group right here being carboxylic acid, it's an amide. So this OH turns to a nitrogen and a hydrogen. So you won't see it on the test, but you will see the benz and amide on your owls.
Okay, and the only part and the only example on the test is this benzeno, this one right here.
Correct.
Okay.
Okay. All right, so now no, I lied. One more orgo question, then we get to the module 7 lecture kind of material. So, what is an example of a saturated compound? So we had this very briefly at the beginning when I started module 5, talked about what unsaturated and saturated means. So saturated means that there's no double bonds or triple bonds. It's all single bonds. All right. So here, pentane ends in ane. Ane indicates an alkane. Cyclopropene, indicates an alkene. 3-pentene also ends in ene, indicates an alkene. Lastly, 2-heptyne ends in ine, which indicates an alkyne. All right. So alkanes are all single bonds, alkenes, double, alkynes, triple. All right. So saturated is all single bonds. So that's going to be A. All right. Saturated is all single bonds. If this was reversed and it said was an example of an unsaturated compound, we'd be looking for an alkene or an alkyne. Any questions here?
Would you pick the highest of the alkene and alkyne at that point?
It would your other answer choices would probably be all alkanes. So you would just choose the alkene or alkyne, and then everything else would probably be alkanes.
Okay.
Okay. Question 16 deals with protein folding. So the tertiary structure of a protein is maintained by A, B, C, or D. So linear sequence of peptide bonds, that does indicate a structure of protein folding, only it's not the tertiary. Linear is the primary structure or the primary folding. All right, so it's not A. A describes primary. B, hydrogen bonds that create alpha and beta sheets. That is, again, this is a type of folding, but it is not tertiary. This describes secondary structure. All right, so alpha and beta sheets describe secondary structure. C, hydrogen bonds, hydrophobic interactions, disulfide bonds, and ionic bonds that create 3D shape. That is the third level of folding, or tertiary structure. All right, so that is our correct answer to this question, C. We're going to go ahead and say what D is, though, just to flush this all out. All right, so C is our correct answer. D, however, describes the fourth level of folding when you have several polypeptide chains joining together. That's your fourth level called quaternary. I don't think I'm spelling quaternary right. Oh, there it goes. Oh, it tried to correct me and then it didn't let me. Okay, so quaternary structure, all right, is when multiple chains come together. So this question, right, if it would have said primary, I would have chose A. If it would have said secondary, I would have chose B. It said tertiary though, so the correct answer is C. Any questions? All right. Couple true false here. So true false. Lock and key theory is when a protein changes to accommodate the shape of the substrate. So the big thing word there is changes. So like the name lock and key theory is when the protein and the substrate are an exact fit. So this answer would be false, right? When a protein changes, that is called the induced fit model. Or theory. Number 18, true or false, enzymes increase the activation energy required to perform a reaction. So enzymes do not increase the activation energy. In fact, they decrease it. Don't know why I'm trying to write instead of type, but I'm committed. So they decrease. So as it's written, it is false. If it would have said decrease, then it would have been true. All right. Last question on our practice exam, number 19. So, this is Le Chatelier's principle. So this is the very last thing that we stopped at on Module 7 lecture. And I ended up deciding to kind of give you in the reference sheet here what kind of what happens basically. So once you identify if the prompt is talking about push increasing or decreasing, then you can just come to this reference sheet and determine that if the reaction is going forward or backwards, okay? So how to use this, I'll show you. I didn't mean to put all these weird highlights on it. Okay. So, according to Le Chatelier's principle, predict the equilibrium shift and the changes for the following reaction if the concentration of HF was increased. All right, so I'm going to find HF and it's increasing. All right, so I'm going to come back to my reference sheet. So this is on the left side of the reaction arrow. Okay, it's on the left side of the reaction arrow. So come back to my reference sheet. So it's increasing. All right, so I'm going to look under this parameter here, and it's on the left side of the reaction arrow. So that means that the equilibrium is pushing forward or to the right. All right, so the equilibrium is pushing forward. All right. Never is equilibrium not going to change. All right. So automatically rule that out when you get to the equilibrium questions. All right. It's a matter of if it's going forward or backwards. So I can rule out anything that has I only in it. And again, you're determining if something's going forward or backwards. So if it's going forward, which we've already determined, it can't be going in reverse. So I'm going to rule out anything that has reverse in it. Next, this particular question asks if the concentration would increase or decrease. So it's asking about the concentration of the other reactant here, sodium anhydride, it kind of looks like. Sodium, I don't know what that name is actually. So if we're pushing forward, we're going to be changing this, both actually HF and NaNH, to the products NH3 and sodium fluoride. So if we're using them up, we're pushing the reaction forward, we're going to end up decreasing those molecules. All right. So we've pushed the reaction forward, which would cause a decrease in this guy. So the correct answer here would be B. All right. Any questions there? Oops. All right. If there's no questions, I know at the beginning it was talked about that you wanted to look over the study guide, and I tried to clarify. It seems you guys want to look over the modified one that I put out there. Modified final study guide. All right, so we'll discuss this because the practice exam is not, it covers a lot of things, but it doesn't necessarily cover everything. 1 second here. Okay. So, right, we said all the bullet points basically represent one question unless marked otherwise. So there are a lot of different kind of questions on here. So be able to name a cycloalkane. All right, so we did this on the practice exam. So that's when you have something with a ring in it, all right? And it's just throwing that word cyclo in front of it, okay? Be able to name an alkane and identify its name. We did 2 or 3 of these on our practice exam we just went through. So determine which alkane has the highest or lowest boiling point in a list of other alkanes. So that looked like that very first one that we talked about where I said we were comparing all the same. That was number 3 here. Okay. All right, so identify a functional groups. So there's a lot of questions where you have to identify functional groups. Identifying functional groups is like big piece. All right, and that is not, functional group is not going to be provided on the study guide. I give you the names, the suffixes, but be able to identify them, that is your responsibility. So that comes back to, if we want to look at that chart, lectures 5. So that all comes back to this chart here. All right, and I had crossed out a few of them, like this guy, this guy, this guy, but the rest you were responsible for. And so hopefully all this practice, we're starting to get these memorized. There was one other that I added, and that's an isopropyl. So that is when you have basically this fork looking guy. All right, isopropyl. All right. So that one, a fork is an isopropyl. That's a multiple choice question where it shows you this fork looking thing and it says, what functional group is this? All right, so that's what another one you have to be able to identify. That's just not on the graphic. All right, let's go back to this. Any questions so far? Okay, so knowing the difference between unsaturated and saturated carbon. So saturated, we talked about this in the practice test, but saturated is all single bonds. Unsaturated means that somewhere there's a double or triple bond present. Okay. Be able to name an alkene and an alcohol. I don't think we did an alcohol actually. But we did alkenes. Alcohols, it's the same way we have been naming, just the suffix is anol, anol. Alcohols are anytime you have just an OH group present. All right. There's some that are a combination of an OH group and other parts, but alcohol's just OH group. Which also leads us to the last point to know what hydroxyl group is. And hydroxyl group is the same thing as an alcohol. It is an OH group. It's just the name for it. All right, any questions on stuff from Module 5? Okay. Module 6. All right. Be able to name a carboxylic acid. We did that. The benzoic acid that was on there. Name ketones. We did not have an example of a ketone, but we had two examples of aldehydes, which are very similar. Only ketones have the ending ANONE, and known. And if we wanted to identify a ketone, all right, ketones are a double bonded oxygen sandwiched in the middle of your carbon chain. So I'm going to go back here. All right, so here we have a ketone, right? I don't like the way they specifically drew this one, but pretend you have this C double bonded to an O, and the chain continues on left and right no matter how many carbons. Say there's one carbon to the right, but 3 carbons to the left. Great, but it's sandwiched, as opposed to an aldehyde where you're going to end with a hydrogen here. All right. Identify aldehydes and know how to name them. We did that. Name amides. We did that. Know the properties of amine. All right. Basically, you just need to know how to use this chart that I'm giving you up here. Come on. Right? You need to be able to know this chart, understand that an amine has, it's the third highest solubility, melting point, boiling point, right? Just know how to compare them. All right. Any questions about Module 6? Okay. Module 7, there's a lot written. So be able to be able to define an enzyme and how it affects activation energy. So an enzyme is something that speeds up a reaction by lowering the activation energy. All right, lowering the activation energy. So that was one of our true-false questions that we did on the practice test. Understand the protein's primary, secondary, tertiary structure, how they're formed. All right, so that was our practice test question where I listed A was primary, B was secondary. All right, so primary structure is how they line up one by one, linearly. Secondary has to do with those alpha and beta sheets. Tertiary is when we have that whole mouthful of different kinds of bonds between our groups. That's actually something that wasn't mentioned in the question before, but let's put that here. So tertiary has to do with the R groups. All right. Quaternary, that's when multiple polypeptides come together. All right. Understand how an enzyme inhibitor affects activation energy. So an inhibitor, I don't think I worded that correctly. So an inhibitor is going to basically block the enzyme from entering, and therefore the enzyme can't lower the activation energy. Okay? Understand how enzymes work. They are reusable. That's important. You can use them over and over again. Consumable would be like you use them once, right? All right. Know the two theories of enzyme fit. So, oh, this is supposed to say induced. I'm finding all my typos. All right, so induced fit, that's like a hug. That's when the enzyme morphs to fit the substrate. Lock and key is when it's a perfect fit. They match exactly. All right, so those are the two opposing theories. Know the three factors that affect enzyme activity. That bullet point is just straight from the test. I think this turns into an all of the above question. I think it says like, what factors affect enzyme activity? A, pH, B, temperature, C, substrate concentration, or D, all of the above, right? You would say all of the above. All right. Know the three parts of an amino acid. This is something we talked about in Module 7, right? You have the R group, which is a variable. You have an amine group and a carboxylic acid group. These are all attached to a main carbon. All right, and then we said know the common or know the structure of these common sugars. Really, honestly, I'll help you out here. You just need to know maltose. Just need to know what maltose looks like because you're going to see the structure of maltose on the exam. And then the same with this one, know the structures of aldohexose, ketohexose, blah, blah, blah. You just need to know the structure of this one because that's what's going to appear on the exam. Okay. And then Le Chatelier's principle. So that was the very last question we just did on the practice exam. So know the factors. That's another all of the above question where temperature, concentration, and volume, those all affect equilibrium, right? I think that's another all of the above. And then B, be able to predict those shifts. That was what we just practiced. And hopefully this on the reference sheet helps guide you. So, does that help? Any questions?
There will be 75 questions again.
50.
Oh, okay.
All multiple choice.
Okay.
So we can use our notes.
You can use the reference sheet that I'm going to provide, which I've been pulling up here. This is this PDF file. This thing,
Oh, okay.
which I've got all crazy annotations on, but we'll clean that up. Anything else? All right, well, if there are no more questions, I would say that concludes our practice exam session. I'm going to upload this to YouTube and then give you guys the link. And if you need me, I'll have office hours tomorrow starting at 5. You can also email me. I know I have one person's email I got to respond to. I'm going to do that after this.
Thank you.
Absolutely.